In 1940, the German military faced a logistical bottleneck that threatened to stall the entire war effort. The planned invasion of Great Britain, Operation Sea Lion, required the movement of heavy artillery, armored vehicles, and thousands of troops across the English Channel, assets that no existing transport aircraft could carry. The solution was an engineering gamble of unprecedented scale, the Messerschmitt Me 321. It was a glider, but one unlike anything the world had ever seen, with a wingspan of 180 feet and a fuselage built from a massive skeleton of welded steel tubing, wooden ribs, and doped fabric. It was a hollow behemoth designed for a single, high-stakes purpose. However, the Me 321 quickly revealed a fundamental mechanical flaw. It was too large to be moved. Initial attempts to tow the loaded glider required a dangerous Troika formation, 3 Bf-110 heavy fighters tethered to a single point. This setup was an aerodynamic nightmare, often resulting in mid-air collisions as the three lead planes struggled to maintain synchronized tension. To save the project from total failure, engineers at Messerschmitt realized the Gigant needed its own internal propulsion. They turned to the French Gnome Rhone 14N radio engine, a 14-cylinder power plant capable of 1,180 horsepower. By retrofitting the wings with 6 of these engines, the glider was transformed into the Me 323 Gigant. This wasn't a clean design process. It was a massive, improvised conversion. The transition from a towed glider to a 6-engine transport required a complete overhaul of the wing's structural integrity to support the weight of the fuel tanks and the vibration of the radio pistons. This transformation created a machine that functioned at the absolute limit of wood and fabric engineering. It was the first true heavy-lift aircraft in history, a massive, slow-moving fabric fortress that bridged the gap between the era of gliders and the future of strategic air transport. As the Messerschmitt 323 Gigant entered active service, it introduced mechanical solutions to cargo handling that would fundamentally change the architecture of transport aviation. Before the Gigant, loading an aircraft was a grueling process of lifting crates through narrow side doors. Messerschmitt's engineers bypassed this limitation entirely by designing the clamshell nose. The entire front of the aircraft's fuselage was split into 2 massive, vertically hinged doors that swung outward, revealing a cavernous, unobstructed hold that measured over 36 feet long and 11 feet wide. This structural feat allowed for a drive-in capability that was decades ahead of its time. An 88mm flak gun, including its prime mover vehicle, could be driven directly into the belly of the plane. To support the weight of these armored loads during the loading process and high-impact landings, the airframe required a revolutionary landing gear configuration. The engineers abandoned the traditional 2-wheel setup in favor of a 10-wheel tandem bogie system. Housed in aerodynamic fairings along the lower fuselage, these 10 wheels worked in synchronization to distribute the aircraft's weight across a massive surface area. This was a critical mechanical necessity. The Mech 233 was often deployed to the primitive, muddy airfields of the Eastern Front, where a standard landing gear would have sunk and collapsed. By utilizing this multi-wheel arrangement, the Gigant could land 12 tons of cargo on soft terrain, effectively operating as a mobile logistics hub. This combination of the front-loading nose and the heavy-duty bogie system established the master blueprint for nearly every strategic airlifter in use today, from the C-5 Galaxy to the Antonov AN-124. While the Me-323 Giant was a masterpiece of internal volume, its external construction was its greatest mechanical liability. In an era where fighter technology was moving toward all-metal monocoques and high-velocity cannons, the Giant remained a creature of the past. Its skin was not stressed aluminum, but doped fabric stretched over a wooden and steel frame. This design choice, made to conserve strategic metals for frontline fighters, turned the world's largest transport into a massive, slow-moving fire hazard. With a cruising speed of just 136 miles per hour, the Giant was a sitting duck for any Allied interceptor that could find it. To counter this vulnerability, engineers attempted to turn the aircraft into a flying fortress. The Me-323 was bristling with defensive positions, often mounting up to 18 7.92mm MG-81 machine guns. These were positioned in the nose doors, the wings, and even top-mounted turrets. During transit, the transport troops inside were often encouraged to fire their own infantry weapons through the fuselage windows, creating a literal wall of lead to deter diving fighters. However, no amount of small-caliber fire could compensate for the aircraft's fundamental lack of armor. The end of the Giant's legacy came not from a failure of its lifting capacity, but from its inability to survive the modern battlefield. In April 1943, during a massive fuel resupply mission to North Africa, a formation of Me-323s was intercepted by Allied P-40 Warhawks and Spitfires. Because the Giant's wings were filled with massive fuel bladders and its skin was flammable fabric, a single burst of incendiary rounds was often enough to down the entire 45-ton machine. The Me-323 remains a haunting lesson in logistical desperation. It was a machine that pioneered the future of strategic airlifting, but was ultimately consumed by the very emergency materials that allowed it to be built in the first place.